School of Management Studies IGNOU presents an audiobook on the course MMPC 005 Quantitative Analysis for Managerial Applications for MBA program. Block 1 Data Collection and Analysis. Unit 4 Measures of Variation and Skewness.
Measures of variation and skewness. After completing this unit, you will learn the concept and significance of measuring variability, the concept of absolute and relative variation, the computation of several measures of variation such as the range, quartile deviation, average deviation, standard deviation, and also their coefficients, the concept of skewness and its importance, and the computation of coefficient of skewness. Introduction. In the previous unit, we were concerned with various measures that are used to provide a single representative value of a given set of data. This single value alone cannot adequately describe a set of data. Therefore, in this unit, we shall study two more important characteristics of a distribution. First, we shall discuss the concept of variation and later the concept of skewness. A measure of variation or dispersion describes the spread or scattering of the individual values around the central value. Different sets of data may have the same measure of central tendency but differ greatly in terms of variation. Significance of measuring variation. Measuring variation is significant for some of the purposes. They are: number 1. Measuring variability determines the reliability of an average by pointing out as to how far an average is representative of the entire data. Number 2. Another purpose of measuring variability is to determine the nature and cause variation in order to control the variation itself. Number 3. Measures of variation enable comparisons of two or more distributions with regard to their variability. And number 4, measuring variability is of great importance to advanced statistical analysis. For example, sampling or statistical inference is essentially a problem in measuring variability. Properties of a good measure of variation. A good measure of variation should possess, as far as possible, the same properties as those of a good measure of central tendency. Some of the well-known measures of variation which provide a numerical index of the variability of the given data are: number 1, range; number 2, average or mean deviation; number 3, quartile deviation or semi-interquartile range; and number 4, standard deviation. Absolute and relative measures of variation. Measures of variation may be either absolute or relative. Measures of absolute variation are expressed in terms of the original data. In case the two sets of data are expressed in different units of measurement, then the absolute measures of variation are not comparable. In such cases, measures of relative variation should be used. The other type of comparison for which measures of relative variation are used involves the comparison between two sets of data having the same unit of measurement but with different means. We shall now consider in turn each of the four measures of variation. Range. The range is defined as the difference between the highest numerically largest value and the lowest or numerically smallest value in a set of data. In symbols, this may be indicated as R equals to H minus L, where R equals to range, H is highest value and L is lowest value. The range is very easy to calculate and it gives us some idea about the variability of the data. However, the range is a crude measure of variation since it uses only two extreme values. The concept of range is extensively used in statistical quality control. Range is helpful in studying the variations in the prices of shares and debentures and other commodities that are very sensitive to price changes from one period to another. For meteorological departments, the range is a good indicator for weather forecast. For group data, the range may be approximated as the difference between the upper limit of the largest class and the lower limit of the smallest class. The relative measure corresponding to range, called the coefficient of range, is obtained by applying the formula coefficient of range equals to H minus L divided by H plus L. Quartile deviation. The quartile deviation, also known as semi-interquartile range, is computed by taking the average of the difference between the third quartile and the first quartile. In symbols, this can be written as QD or quartile deviation equals to Q3 minus Q1 divided by 2, where Q1 is the first quartile and Q3 is the third quartile. The relative measure corresponding to quartile deviation, called the coefficient of quartile deviation, is calculated as coefficient of QD or quartile deviation equals to Q3 minus Q1 over Q3 plus Q1. The quartile deviation is superior to the range as it is not based on two extreme values but rather on middle 50% observations. Another advantage of quartile deviation is that it is the only measure of variability which can be used for open-end distribution. The disadvantage of quartile deviation is that it ignores the first and the last 25% observations. Average deviation. The measure of average or mean deviation is an improvement over the previous two measures in that it considers all observations in the given set of data. This measure is computed as the mean of deviations from the mean or the median. All the deviations are treated as positive regardless of sign. In symbols, this can be represented by AD or average deviation equals to x minus mean over n or x minus median over n. Theoretically speaking, there is an advantage in taking the deviations from median because the sum of the absolute deviations, that is, ignoring the plus minus signs from median, is minimum. In actual practice, however, arithmetic mean is more popularly used in computation of average deviation. For group data, the formula to be used is AD equals to sigma f into x minus mean over n. The relative measure corresponding to the average deviation, called the coefficient of average deviation, is obtained by dividing average deviation by the particular average used in computing the average deviation. Thus, if average deviation has been computed from median, the coefficient of average deviation shall be obtained by dividing the average deviation by the median. We can say that coefficient of AD or average deviation equals to AD over median or AD over mean. Although the average deviation is a good measure of variability, its use is limited. If one desires only to measure and compare variability among several sets of data, the average deviation may be used. The major disadvantage of the average deviation is its lack of mathematical properties. This is more true because non-usage of signs in its calculations makes it algebraically inconsistent. Standard deviation. The standard deviation is the most widely used and important measure of variation. In computing the average deviation, the signs are ignored. The standard deviation overcomes this problem by squaring the deviations, which makes them all positive. The standard deviation, also known as root mean square deviation, is generally denoted by the lowercase Greek letter read as sigma. In symbols, this can be expressed as standard deviation equals to square root of sigma x minus mean whole square divided by n. The square of the standard deviation is called variance. Therefore, variance equals to square of standard deviation. The standard deviation and variance become larger as the square of the data becomes greater. More important, it is readily comparable with other standard deviations, and the greater the standard deviation, the greater the variability. For group data, the formula is standard deviation equals to square root of sigma f into x minus mean whole square divided by n. The formulas for standard deviation are mathematically equivalent to the formula mentioned so far, and they're often more convenient to use in calculations. These formulas are standard deviation equals to square root of sigma fx square over n minus sigma fx over n whole square, which is equal to square root of sigma fx square over n minus mean square. It is also equal to square root of sigma fd square over n minus sigma fd over n whole square into I, where d equals to x minus a over I. Remarks. If the data represent a sample of size n from a population, then it can be proved that the sum of the square deviations are divided by n minus 1 instead of by n. However, for large sample sizes, there is very little difference in the use of n minus 1 or n in computing the standard deviation. The standard deviation is most commonly used to measure variability, while all other measures have rather special uses. In addition, it is the only measure possessing the necessary mathematical properties, like combined standard deviation, to make it useful for advanced statistical work. Coefficient of variation. A frequently used relative measure of variation is the coefficient of variation, denoted by CV. This measure is simply the ratio of the standard deviation to mean expressed as the percentage. Hence, coefficient of variation or CV equals to standard deviation over mean into 100. When the coefficient of variation is less in the data, it is said to be less variable or more consistent. Skewness. The measures of central tendency and variation do not reveal all the characteristics of a given set of data. For example, two distributions may have the same mean and standard deviation but may differ widely in the shape of their distribution. Either the distribution of data is symmetrical or it is not. If the distribution of data is not symmetrical, it is called asymmetrical or skewed. Thus, skewness refers to the lack of symmetry in distribution. A simple method of detecting the direction of skewness is to consider the tails of the distribution. The rules are: data are symmetrical when there are no extreme values in a particular direction so that low and high values balance each other. In this case, mean equals to median equals to mode. If the longer tail is towards the lower value or left hand side, the skewness is negative. Negative skewness arises when the mean is decreased by some extremely low values, thus making mean smaller than median and median smaller than mode. If the longer tail of the distribution is towards the higher values or right hand side, the skewness is positive. Positive skewness occurs when mean is increased by some unusually high values, thereby making mean more than median and median more than mode. Relative skewness. In order to make comparisons between the skewness in two or more distributions, the coefficient of skewness given by Karl Pearson can be defined as Sk equals to mean minus mode over Sd, that is standard deviation. If the mode cannot be determined, then using the approximate relationship mode equals to 3 median minus 2 mean, the same formula can be reduced to Sk equals to 3 into mean minus median over standard deviation. If the value of this coefficient is 0, the distribution is symmetrical. If the value of the coefficient is positive, it is positively skewed distribution. Or if the value of the coefficient is negative, it is negatively skewed distribution. In practice, the value of this coefficient usually lies between plus minus 1. When we are given open-end distributions where extreme values are present in the data or positional measures such as median and quartiles, the formula for coefficient of skewness given by Boley is more appropriate. The formula is Sk equals to Q3 plus Q1 minus 2 median over Q3 minus Q1. Again, if the value of this coefficient is 0, it is a symmetrical distribution. For positive value, it is positively skewed distribution, and for negative value, it is negatively skewed distribution. Now let's summarize the unit. In this unit, we have learned how the concepts of measures of variation and skewness are important. Measures of variation considered were the range, average deviation, quartile deviation, and standard deviation. The concept of coefficient of variation was used to compare relative variations of different data. The skewness was used in relation to lack of symmetry.
We were listening to the audiobook by the School of Management Studies IGNOU for MBA program, course code Mmpc 005, Quantitative Analysis for Managerial Applications. Voiceover by Harpreet Kaur. Edited by Savita. Program assisted by Tarannum Jahan and Jagbandhu Jana. Program produced by Dr. Manoj Kumar Singh. This program was brought to you by Electronic Media Production Center of Indira Gandhi National Open University.